My name is Andy Westhoven, Regional Agronomist with AgriGold Hybrids, and today I'm looking at a potassium deficient cornfield. And what's unusual about this particular year, we've received plenty of rainfall. Years that I have seen potassium deficient fields are usually drier years, like in 2012 during the drought year, where it was exceptionally hot, exceptionally dry, and regardless of potassium being in the soil, fertilizer being abundant, the roots were not able to intercept any of that because there was no soil moisture. This year, we've had plenty of moisture. There was at least 200 pounds of potassium potash put on this field. So we know the fertilizer's there. We know we've had rainfall to help move the potassium to where it's needed, closer to the roots. So nonetheless, we are still seeing potassium deficiency. You can see the lower leaves are yellow, and as we move further up the plant, we can see the foliage turns greener, healthier. Potassium is mobile within the plant, so the plant will actually take potassium from the lower part of the leaf or the plant and move it to the newer, healthier growing portions of the plant. Other identification parts: when you look at these leaves, potassium will start at the tip of the leaf and work towards the stalk. It will also die from the outside leaf margins. They will become yellow and then brown or necrotic, and they will become brown and yellow towards the center or the midrib of the leaf. We can see some other leaves here showing again that yellowing towards the outside of the leaf margins. That should improve as we move further up the plant. Now, we did take some plant samples to show that this field was actually potassium deficient. So now looking at the plant sample analysis, first you can see here in the top right, this is a healthier corn sample. We took this from an area that was not showing any potassium or really any deficiencies whatsoever. It was very healthy and green, but however, when you look at the orange squared area, see that the percent potassium in this plant is 1.76. The normal range is 2 to 2.5%. So even the healthy plants, while not showing any deficiencies, are actually deficient. We look down at the bar chart, and it actually shows this area again being low, not necessarily deficient. When we look at one of the unhealthy plant samples, we can see that our percent potassium actually drops to 0.72. We're extremely deficient, and this bar chart actually shows that we are. Now, one of the things that also jumps out when we look at the unhealthy plant samples is that the magnesium level is extremely high. We can see that the plant sample shows that it's 0.75% of the leaf is magnesium. A normal range is 0.13 to 0.3, so we're extremely high. You can see the bar chart here actually shows it being very high, magnesium. When we jump to this other ratio that we can look at, it's potassium to magnesium ratio. We have a exactly 1 to 1 ratio. What we should have in the plant is a 10.5% potassium to magnesium. So we are extremely low. We already know that we're low in potassium, but basically that is one of the biggest factors here. Now, because our potassium to magnesium level was extremely high, one thing that we can investigate is Mulders Chart. And you can see it's essentially this globe with all the different nutrients around it and how they interact within the plant. The ones I have highlighted are potash and magnesium. You can see this bright pink line that has a double arrow. So basically what this tells you is that if magnesium is extremely high, it's going to limit potash uptake. Contrastly, if potash is extremely high, then magnesium uptake will be inhibited. If potash was applied at desired levels, magnesium may be still too high in the soil for the potash to be taken up by the plant. So what you need is a really good nutrient balance among all nutrients, not just those two in general. So now, because we know that these two can in fact inhibit one another's uptake, we need to investigate the soil analysis. So now we are looking at the soil test report for this specific field. And the two boxes I have highlighted, first we'll start on the left. I have potassium and magnesium. And specifically, the potassium is listed in parts per million. It has 34 parts per million, and it is rated very low. Right next to it, the magnesium, also rated in parts per million, is 420, which is very high. So as we just talked about on Mulders globe, those two do interact with one another. What is rather interesting is if you move over to the percent cation saturation, we notice that percent calcium is 0.7%. And with this field that has a CEC of 12, it would be really nice to see at least a minimum of a 3 to maybe 4% potash. And the magnesium level is 28.7. Now, while most fields in Indiana, at least Indiana, have a very high mag level, 28 is still pretty high. Certainly not excessive, but because the percent potash is only 0.7, that's the reason we are seeing the deficiency within this field. Specifically, I would like to see the mag ratio on this heavier soil type really at about 15 to 18%. So we could also improve the magnesium level, but honestly, you can tell that we need to increase our potassium level as well. And even though this grower did apply some potassium, this is a rented farm, so we know those situations you can run into between year and year contracts and such. And so one thing that we also need to think about, specifically last year this field was soybeans. With the extreme drought and then the late rains, soybeans could actually have taken up quite a bit of potassium late in the season, leaving this field more deficient than it typically was. So moving forward, we could always address the potassium level, but nonetheless we know truly why we are seeing the potassium deficiency as it's within the leaves and within the soil. We just have a counterbalance here. So certainly we know why we are seeing deficiency within the leaves and within the soil. We look at the mag level also. We can tell those are very high within the plant and within the soil, which has to be helping to limit our uptake of potassium.